This video is a non-technical presentation on decentralized publishing, and really what it's going to cover is different types of internet publishing models and how they've evolved over the course of the internet's life. And so this is going to be very high level and very non-technical, and it's going to be very picture heavy. And but I wanted to create it as a precursor to a more technical video where I'm going to cover some of the more cutting edge decentralized publishing models and some of the tools I've built to help people publish in a decentralized way to avoid censorship and circumvent any sort of government control of content. So let me just dive in here to the diagrams. This is a picture of basically the modern internet, the way it's been up until now, like especially in the 90s and the early 2000s. This is how the typical internet experience went, is you'd be over here as a client, and your computer, if it's connected to the internet, it's going to have this IP address. It's going to look something like this. And the way that computers use IP addresses is the same way that people use telephone numbers. You know, if you're going to call someone, you're going to dial their telephone number. Your computer basically does the same thing when it talks to, say, Google. When you go to google.com, that's going to get translated into an IP address, and your computer is going to go and request that IP address, or the web page served by that IP address. And so, and then typically your web browser is not directly connected to the internet. It goes through a firewall. This might be the firewall in your home, or it might be like the Great Firewall of China. Like it might actually go through several firewalls, and the government may control some of them. And then finally, there's this thing called the DNS, the Domain Name Service. And you know, when we go online, we want to use human-readable domain names like google.com. But computers don't work like that. Like I said, they use IP addresses. So the first thing that your computer does when you type google.com in your URL bar is it goes to a domain name service and says, hey, what's the IP address associated with google.com? And it comes back and says, okay, now I can call them. And then it goes through your firewall and it calls google.com, and that's how, you know, if you ever looked up information on Google, that's how it works. And this is problematic. This architecture is problematic in several ways from the lens of censorship. If you want to prevent a government from censoring content, then there are several attack vectors. So let me just walk you through. The first attack vector, and the most blatantly obvious, is the firewall, and everybody has heard of the Great Firewall of China. And that's how they block. They sit in between all of the citizens in their country and everything outside their country, and everything gets piped through their firewall, and so they can choose what passes and what doesn't pass. And that's the most obvious way. Another way that was more common in the past was to actually just attack the physical server, like to physically go and disconnect it. That's less common for two reasons. Because most servers these days aren't physical. They live in the cloud, and they live usually in several different clouds. And so even if, say, a government can strong-arm Amazon Web Services, a really sneaky website would probably be able to detect that and replicate their server faster than they can be taken down by hopping across many different cloud service providers. And so in order to be effective in this kind of censorship, the government has to coordinate, usually across countries and across data centers, and do it at once. And they do still do this. This is a common thing. I see this in the news all the time, this type of attack. And it's not to say it's not effective. It's sort of caveman-ish. It's like this is how you would do it in the 90s, and it's just not as effective today. The other common way, which is very effective, is to obtain the the domain name, to go to the domain name service, and I think the U.S. is the only one that's successfully done this. Most countries like Turkey and China and other like Egypt, they usually have a firewall, and that's the most commonly used form of censorship outside the U.S. But in the U.S., the internet kind of started here, so the U.S. government has a little more control, and they have actually successfully overtaken people's domain, served the domain name service with enough legal power to just take someone's domain name. And so that's kind of the three most common ways of censoring information. So let's take a look, in contrast to this sort of model, and actually let's just take a look at another model. So now we can talk about publishing models. Let's leave the censorship thing to the side for a minute, and let's just talk about how content gets published on the internet. So this would typically be like my laptop here that's recording this video. If I was to create a website, which I do all the time, that's what I do as a profession, I would write the software that makes it up on my computer, and then I would push it up to a server, and like christroutner.com, and then if you want that information, you would, this would be you or anybody else in a web browser, and they would go to christroutner.com, and they would pull that content down. And that's the model we just talked about here. And so this is like kind of the conventional publishing model. Well, these days, in the last 5 years, it's been this model's changed just slightly, and it looks more like this, where instead of uploading the data directly to the server, I'll publish my code to GitHub, and then I'll log into the server and I'll pull the updates from GitHub. And so it's just a slight difference. I mean, it's really basically the same thing. It's just this is more technically correct. Okay, so let's kind of jump back into the censorship lens and see what effects this has on censorship. So this is all still happening in this conventional model of the internet and the way that it can be attacked and censored. And so some of the earliest ways to combat censorship sort of grows this conventional publishing model to something like this, where you might have a proxy or a VPN sitting between the server and you. And so this is how people, say, circumvent firewalls in China or Turkey or other countries that are common, that commonly use this firewall tactic, is you can set up another computer in some other country. So maybe this person can't access the server directly because it's blocked in their country. So what they can do is they can set up a proxy or a VPN that their web browser goes through, because they can access this computer and this computer can access the server. And so that's a common way of circumventing that sort of firewall level censorship, though it doesn't do anything to mitigate against the DNS attack or the physical attack. And so this is a pretty common anti-censorship technique. And but building on top of this sort of new way of publishing, this new more technically correct way of publishing, I don't have the one loaded that I wanted. Decentralized publishing. So GitHub, that was down here, that could really be replaced by the IPFS network and the BCH blockchain. Let me back up a step. So GitHub, as I showed here, is the modern way. You can go to github.com. They were recently purchased by Microsoft. This is like the conventional workflow for publishing websites today. And these tools that I'm going to show in the next video how to use show how to move from this publishing model to this publishing model. And so the BCH blockchain is Bitcoin Cash. It's the currency. Hopefully you're familiar with that. IPFS is the interplanetary file system, and it's a network, and it's very similar in many ways to BitTorrent, if you've ever downloaded a torrent file. And but it's also got some inherent. It's got more modern networking features, and it's also got this system of hashing and the peer-to-peer networking is just a little bit more sophisticated. And so the problem with the IPFS network is that everything on the network is a hash. And let me show you what I mean by a hash. That's not... let's see. Well, I can... where was I? Okay. One second, sorry. Okay, here are examples of hashes. These are hashes, especially in IPFS. They start with a QM here, but the point that I'm making is that they're not human readable. Like, you can't look at that and just grok like immediately what that's about. And so that's kind of a problem. And also, there's this double-edged sword in IPFS where anytime something changes, it gets a new hash, and that's good because it guarantees that no one's tampered with the data, but it also means that every time you want to change something, everything changes, and you need to let everybody else know what that change is. And so there are these limitations with the IPFS network that are still unsolved problems, or at least the solutions are not optimal. And so I propose that is where the Bitcoin Cash blockchain could come in and really help. And so what you end up doing is, this is a replacement for this original model. The Bitcoin Cash blockchain becomes your domain name service. This is what sort of tells you where to find the content. And then the server becomes the IPFS network. And in a previous video I had discussed how IPFS is different than the regular internet. In the regular internet, everybody gets their content from a server, from one server, and so it's very centralized, and that's why you can attack that server, and that's why that's traditionally been very effective. But in IPFS, this is where the BitTorrent stuff comes in, where if I publish some content to the IPFS network and then the server pulls it, we can both share our content to the internet. And then if anyone on the internet downloads that content, they will also share it to the regular internet, and we'll all be sharing it. So it has this property where the more popular a piece of content becomes, the harder it is to stop and the easier it is to distribute. And so this is called the Streisand Effect, which is a silly name, but it's like a very serious phenomenon that is not yet fully appreciated. And IPFS and Bitcoin both gain a lot of power from this Streisand effect, and you can go to Wikipedia and Google it. It's a real thing, and it's definitely worth checking into. So that's what this model is showing: is this Bitcoin Cash blockchain is replacing this block, the DNS, and the IPFS network is effectively the server. You can think of it as the server. And so now, sort of merging that idea with this so if this is like the state of the art, this is the modern web developer experience, you're publishing it here, and transitioning to a model that looks more like this, and these tools that I've built that help you do this, is what you do is when you build your website and you're ready to upload it, you publish it directly to the IPFS network, and then that's going to give you a hash, and it's going to look, like I said, just like this. You'll get a hash like this, and then there's a tool I built called Memo Push, and I'll show that here in a minute. But you push the hash to the BCH blockchain, and then over here on the server is running software that automatically monitors your Bitcoin Cash address for these kinds of updates. And when it detects one, it will pull that information down from IPFS and start seeding that content to the rest of the internet. And at that point, you can safely disconnect from the internet because your server is going to be sitting there serving the content for you. And the user experience is exactly the same. That's probably the most important thing to take away from here, is that this part, the people just browsing content in the web browser, that hasn't changed at all. From the user standpoint, this is no different. And that's really powerful. People don't like it when you move their cheese. When it's hard to get people to adopt new behavior. And so the power of this is that it does not change the end user behavior at all. They don't need to know that any of this is happening behind the hood. But the power in this is that this IPFS network and this Bitcoin Cash blockchain, these are ubiquitous. They exist all over the world. These are a mesh network of peer-to-peer computers that are in existence right now and that anybody can leverage, and can't be censored by any government. There have been a handful. These technologies are fairly new. Bitcoin's been around for 10 years. IPFS has been around for 5-ish, and but they're widely distributed, and there's a handful of cases of governments going up against these technologies and failing. And that's the important thing, is if you want to distribute content and it's hot and you want to be sure that the government can't stop it, you need to leverage these networks. And this is how people are going to rise up in the future and take control of their countries and get wrest control away from the politicians. And the other cool thing about this little chunk over here is that if people don't even know about your server, like let's say your server is just in a country and it's just known within that country and nobody knows about it, but somebody shares a link somewhere, anyone on the IPFS network can get your data, and anyone who can access the Bitcoin Cash blockchain or a web browser and go to memo.cash, which is a website. Let me just show that to you. This is an example of a test, and I'll go into more detail about this in the next video, but this is just the Bitcoin Cash blockchain, and this is like Twitter. This is like a Twitter that writes directly to the Bitcoin Cash blockchain, and this is how the updates are getting published, and how the web server knows what hash to retrieve from the IPFS network. And so I suggest you go here to memo.cash and play with this. This service is awesome. It rides on top of the Bitcoin Cash blockchain, and it uses this new model, or at least this part. And but the point is that the end user experience hasn't changed. That's good. But you've also drastically expanded the number of people who can access your content. Like, people can easily mirror your content, and random people on IPFS can browse your content. Other people can mash up your content, like any web app or any distributed application can download your content and just start using it. And that's really powerful if that's what you want. That's a really powerful feature that basically you can wipe that whole part out and everything else keeps chugging along. And so this has been an overview of the different this decentralized publishing model that I'm moving forward with. If this is exciting to you and you want to learn more technically how to use some of the tools and get started, go ahead and check out the next video.